Hi students. Now Bronsted and Lowry acid base theory. Bronsted and Lowry acid base theory. Acid base theory. Bronsted Lowry acid base theory. Today we'll discuss about. So according to this theory introduced in 1923. So according to this, 1923 it is introduced. According to it, an acid is according to this theory, according to this theory or according to it, acid is a substance. Acid is a substance or molecule, ions. Acid is a substance or molecule or ion which has tendency to release the proton. Proton means H plus ion only. So according to Bronsted, he said proton, but according to Arrhenius theory, they said what? H plus ion, hydrogen ion. They didn't say about proton, but here this Bronsted said proton, which is release H plus ion there. But here, which is release, the tendency to release proton is known as acid. The tendency to release proton is known as acid. So also known as, which is release proton, that we will call protogenic. Protogenic means proton releasing capacity or mother, like protogenic, protons born from where, that we will call protogenic. And similarly a base has tendency to accept the proton. So which is accepting proton, that is base. Which is releases proton, that is acid. Example, HCl plus. These base we will call protophilic. That means proton liking part. Which is accepting proton, that is protophilic. Which is releases proton, that is protogenic. Okay, now HCl plus H2O gives rise to H3O plus Cl minus. Here, which is release H plus ion, this is. So now this is acid, which is accept proton, this is. Now this is base. According to Bronsted and Lowry theory, base means which is accepting proton. In this reaction, HCl acts as a acid because it donates a proton to the water. Water molecule, because donate the proton to the water molecule. Water on other hand behaves as a base. So water behaves as a like base by accepting proton. So this is a Bronsted theory. Next, Bronsted and Lowry theory is also known as proton donor and proton acceptor theory. Proton donor and proton acceptor theory. Proton donor and proton acceptor theory also we will call Bronsted theory, because here proton only playing major role. Next, some other example. CH3COOH plus H2O gives rise to H3O plus CH3COO minus. Next, second example also, NH4 plus H2O. Here H3O plus will come plus NH3. Now here this is acid, this is base. Third example, NH3 plus H2O gives rise to NH4 plus OH minus. So in this reaction, this is base, this is acid. Water is act as base as well as acid. So how, see, in this reaction 1 and 2, water is acting as base, while in the reaction 3 it is acting as an acid. The reaction 3 it is acting as acid. This water can donate as well as accept H plus ions and can act as both acid and base. So the species like H2O, NH3, acetic acid, NH3 and water, in this 3 which can act as both acid and base are called amphoteric. So this one also we will take like COO minus, we can add to water, means we will get CH3COOH plus OH minus. In this reaction, this is now accepting proton, so this is now base, this is acid. Same in this reaction, this is acid, this is base, like so water, ammonia means NH3 here base. NH3 how it is changes into acid, see, in this reaction reverse, like NH3 accept proton changes into NH4 plus. So now it is base. Same NH4 plus when dissolved in water releases H plus ion. So now this is acid. So that only H2O, NH3 and CH3COH can act as both acid and base are called amphoteric. Amphoteric nature means amphiprotic means it is like acid as well as base, like it is behaves. Moreover, according to this theory, acid ion on losing a proton becomes a base called conjugate base. called conjugate base. So according to this theory, what happened when acid loses, like one example take CH3COOH plus H2O, CH3COO minus plus H3O plus. Okay, in this equation which is losing a proton becomes a base. This is acid, no? Acid losing proton means it is changes into like base, that is conjugate base, C base, while the base by accepting proton changes into acid. Now it is a base changes into acid because capability to release H plus ion, no? Acid, conjugate acid, called conjugate acid. So here to here loses. What is that? H plus ion. Here to here accepting H plus ion. Accept H plus ion. Okay, now COOH minus is a conjugate base. CH3COOH is a conjugate base of CH3. This is conjugate base of acetic acid. Conjugate base of acetic acid is a conjugate base of acetic acid, while H3O plus ion is conjugate acid of water. Conjugate acid of water.